Be in here. Okay, so one-to-one functions and their inverses. So we're going to be doing inverses of functions today, which we've learned that before. And we've also learned what a one-to-one function is. So just a reminder of how things work. What makes something officially a function is each x has only exactly one y value. Now we can tell if something is a function if it can pass the vertical line test. So if I draw vertical lines and it never crosses my pencil twice in one vertical line, it's considered a function. Now something does not have to be a function to be considered one-to-one, and vice versa. So just keep that in mind. They don't go hand in hand. I mean, they kind of go hand in hand, but one doesn't affect the other. So what makes something a one-to-one function is, or what makes something one-to-one, it doesn't have to be a function, sorry. What makes something one-to-one is the other way. Each y has only one x. So how we test that is the horizontal line test is one way. If we draw horizontal lines across our graph and it hits your pencil in two places, it is not considered one-to-one. You have to be able to draw horizontal lines and it only crosses that horizontal line one time. Now also, another way to determine if something is, let's say you weren't given a graph. If I said to you, is this function one-to-one? What you can do is find the inverse of that function. And if the inverse is also a function, if the inverse also passes the vertical line test, it's considered one-to-one. Does that make sense, everyone? So we have those two ways we're going to test. So if we're given a graph, we can test if it's one-to-one by the horizontal line test. So let's determine if these are one-to-one. First of all, I'm just asking for kicks and giggles, is this considered a function? Does it pass the vertical line test? Yes. Is it considered one-to-one? Does it pass the horizontal line test? If I draw horizontal lines, is it ever hitting that horizontal line twice? Yes, to the copy room. Thank you so much. No, so it's one-to-one. Okay, let's try this one. Is it considered a function? If I were to draw vertical lines, would all be good? Yes, but is it considered a one-to-one function? No, look, on the horizon, it's hitting in two places. So at the that y has two x values, correct? Okay, so this would be not one-to-one. Is this considered a function? Yes. Is it considered one-to-one? Yes, right? It never hits your pencil twice in one spot on the horizon. Okay, awesome. How about this circle? Is it considered a function? And it's not considered one-to-one either, right, everybody? So this one was, this one wasn't one-to-one. Okay, you guys are doing great. Okay, so another way to, like I said, to determine if something is one-to-one, if you find the inverse and the inverse also is a function, it's one-to-one. So just looking here, just a reminder, if I give you a set of xy points right here, 1, 2, 2, 3, 3, 5, our domain would be 1, 2, and 3. Our range would be 2, 3, and 5, right, everybody? Now, to find the inverse of that xy point, does anyone remember how we find it? What's the inverse of 2, or 1, 2? 2, 1. You just switch x and y, right? That's how we find the inverse of an xy point. So this is inverse is this. This one's inverse is this. This one's inverse is this. So that's a good reminder. And so just a reminder, look, notice this one's domain will be the inverse's range. And vice versa, this one's range will be this one's domain, right, everybody? We know that. So if you know the original's domain and range, you also know the inverse's domain and range, because you just switch them. All right, so it says graph the function and its inverse. So here's how I do it, first of all. What I would do is just graph the original function, and then write down the xy points, and then switch them, and then you'll have both, the function and its inverse. So how I would start out is I would say, okay, given f of x is root x minus 3, I would write down the parent function. That's the theme of this unit. To graph things, we would do parent function, and then we perform the shift. So wouldn't the parent function be root x? So let's write down some parent function xy points here. So if I plug in -1, I can't, right? Where do I have to start? What's the domain here? 0, yep, 0 to infinity, greater than or equal to 0. So starting at 0, I get 0. The square root of 1 is 1. Square root of 2 is a decimal, skipping that, 3, 4. Square root of 4 is 2. 5, 6, 7, 8, 9. The square root of 9 is 3. Those are the parent function points, correct? We're not going to graph those. It's just allowing us to then perform our shift. In words, you would describe the shift of right 3. Isn't that the only shift? So that's an x shift. So we'll add 3 to all of our x's, and I'm going to write down my official xy points for my original function. These are the xy points for the shifted square root. So we would have 3, 4, we're adding 3, 7, 9, 10, 11, 12. Okay, 0, 1, the y's didn't change. And now we can graph those. Over 3 up. 0 isn't that my starting point? If 0, 0 was your starting point, you shifted it, now 3, 0 is your starting point. Over 4 up 1, and then over 7 up 2, and then isn't that all it will fit? So I've graphed it. Now to find the inverse, we could go through and use math to find the inverse and then do it the hard way, but isn't it easier just to take your xy points and switch them? That will be the inverse, so 0, 3, 1, 4, and then 2, 7, and then 3, 12. Those are your inverse points. So let's graph that. Over 1 up 1, no wait, sorry, over 0 up 1, 2, 3, over 1 up 1, 2, 3, 4, over 2 up 1, 2, 3, 4, 5, 6, 7. And that's all that will fit. We've graphed the function and its inverse. Pretty easy, right? Okay, awesome. So let's talk about this. What is the domain of the original function? 3 to infinity. So then don't we automatically know this one's range is 3 to infinity? The inverses, anyways. The range on my square root, isn't it from 0 to infinity? If that's true, then the inverse's domain would be 0 to infinity. And if you check it, it does work. Look, the domain was 0 to infinity and the range was 3 to infinity. Okay, question. Is the inverse a function? Look at the inverse, it's pink. Is the inverse a function? Yes. Is it 1 to 1 then? If the inverse is a function, guys, it is 1 to 1. Yes. Does that make sense? Okay. I also want to point out, just a reminder, because some things we need to know about inverses, we need to know everything. These points are being reflected over the y equals x axis. This slanted line, y equals x. Do you see how if I stamped across, they would match up? Okay. Let's do another one. Okay, it says, so given this original function, graph the function and the inverse. So I would start out by saying I'm going to do the parent function x squared. I'll make an xy chart for that. So can't I plug in anything into a quadratic? Yes. So we'll start with -2, -1, 0, 1, and 2. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. But now we're transforming it down 2, aren't we? So we'll take our y values and subtract 2. These are our official quadratic points. So our x's didn't change. -2, -1, 0, 1, and 2. And now we'll subtract 2. So 4 minus 2 is 2. 1 minus 2 is -1. 0 minus 2 is -2. 1 minus 2 is -1. And then 4 minus 2 is 2. So there's our official points. So over -2 up 2. Over -1 down 1. Over 0 down 2 units, over 1 down 1 unit, over 2 up 2 units. There is my original function. And then the inverse, I'll do it in orange. We switch our x and y's. So now it would be 2, -2, -1, -1, -2, 0, -1, 1, and then 2, 2. So graphing those. We're going over 2 units, down 2 units. Check. Over -1, down 1. It's going to end up right there on top of that point. Then over -2 up 0. Then -1 up 1 unit. Over 2 up 1, 2 units. Can't we see it? It's a sideways parabola connecting it over. Okay, so question for you is, look at the inverse. The inverse is orange. Is the inverse a function? No. Look, there doesn't pass the vertical line test. Therefore, it must not be 1 to 1. Does everybody see? The function is not 1 to 1 if the inverse is not a function. Okay. Now, what's happening here? Let's see. I want to show you something, okay? If I was to say find the inverse of this using math, you would switch x and y. So you have x is equal to y squared minus 2. Then we would add 2. So we have x plus 2 equals y squared, don't we? Then we would square root both sides. When solving and taking square root, what do I need? Plus or minus. Isn't that creating the plus is the top half of the square root, the minus is the bottom half? So a reminder, plus and minus is what makes an inverse not a function, right? Everybody, it's the plus and minus thing. All right, so the domain, let's just look at the original function. The domain of the original, the red thing is? Good, negative infinity to infinity, so all real numbers. Therefore, my inverse's range is all real numbers. What is the range of the red function? Negative 2 to infinity, therefore, the domain of the inverse also must be negative 2 to infinity. Is this seeming hard to anybody, or does it feel all the same stuff we've learned? Yeah. Okay, so if, okay, let me say this again. I think this is what you're talking about. If you have an original function, and I said to you, okay, let's say I just said to you, is this 1 to 1? What you would do is find the inverse. If the inverse is a function, it's 1 to 1. If the inverse isn't a function, it's not 1 to 1. So because of the plus or minus, it now is not a function, therefore this is not 1 to 1.
I thought that like a function was the 1 to 1 of the inverse.
Say that again.
So like when we were learning like before.
Should I go back?
No. I'm talking about like last semester. I thought we were talking about the fact that like a function meant like it could pass the
Vertical
line test or a normal function, and then when we okay, I don't know.
Okay, everybody make sure you don't connect them. Something can be 1 to 1 and not a function. And vice versa. Something can be a function, not 1 to 1. Does that make sense? They don't have to go together. It's just, let's say, okay, so let me explain something one more time. Everybody listen. This is going to help. If I give you a graph and I say, is this 1 to 1? All you have to do is the horizontal line test. If it passes the horizontal line test, it's 1 to 1. Does that make sense? Now, here's the thing, guys. What if I give you an equation? A graph is easy to see. If I give you an equation, and I say to you, so this is where we're going with this. If I say to you, is this function right here, if I said to you, is this 1 to 1? You don't have a graph, do you? So you don't want to have to graph it. So an easier way would be to find the inverse and then just look and say, is the inverse a function? If so, it's 1 to 1. Because we know what graphs look like. We've graphed a lot. So let's practice that. So all I'm asking is this function 1 to 1? You'd say, well, I don't know because I don't have a graph. I mean, you know what I mean? Is this 1 to 1? So let's find the inverse, and if the inverse is a function, it is 1 to 1. So how do we find an inverse? Switch x and y, correct? So x is equal to 3y plus 2, and then solve for y. So what do we do? Subtract 2, so we have x minus 2 equals 3y. Then what? Divide by 3. So now my inverse, y is equal to, y inverse I'm going to call it. Y inverse is, now look, 1/3 x minus 2/3. Is a line a function? Yes, so the inverse is a function, therefore the original is 1 to 1. So, yes, we could graph it, and then we could do the horizontal line test. Let's just, I don't know, a different way of looking at it, yeah.
Won't everything that's linear be 1 to 1?
Yes, good point. Linear inverses will always be linear, therefore they will always be 1 to 1. All right, let's do this one. I'm asking you, is this function 1 to 1? Well, let's find the inverse, and if the inverse is a function, we're good. If not, it's not 1 to 1. So how do we find the inverse? So x is equal to y squared plus 1. Now solve for y. X minus 1 equals y squared. Then square root. Square root, when you're solving and taking a square root, you need a plus or minus. So our inverse, y inverse, is equal to plus and minus the square root of x minus 1. Now, is this a function? The inverse isn't a function, therefore it is not 1 to 1. All good? Okay. Let me just see though. Did I skip graphing one? I can't remember. I think we did them. Okay. We'll keep going. Okay, it says find the inverse, and then is the original function 1 to 1. So we'll find the inverse, and then we know how to determine. So switch x and y, so we have x is equal to y to the 5th minus 3 over 2. So what would I do first? Times by 2, so then 2's gone, right? Then what?
Let's
Add 3, so we'd have 2x plus 3 equals y to the 5th. Then we'll take the 5th root. Do odd roots get plus or minuses? Nope. So we have the 5th root of 2x plus 3 equals y. If there's not a plus or minus, it passes the vertical line test. This inverse here is a function. Odd roots are good. So you would say, yes, this function is 1-to-1. Since the inverse is a function, it is 1-to-1. Just a different way of determining. Because otherwise you'd have to graph. You would have to graph this, and then you would have to do the horizontal line test. Does that make sense? Just two different ways of finding if it's 1-to-1. Okay, let's do this one. This one is the one that, guys, it can no longer be hard for us. This one always throws people off. I don't want to see anyone missing this on the test at this point in 1050. Write this one down. Okay, in 1010, a lot of people missed it. Okay, so you'd say, okay, it says, is the function 1-to-1? Find the inverse. So we'll say, okay, we switch x and y. So we have x is equal to 2y plus 3 over y minus 1. Now from here, we've seen this in 1010. The problem is, isn't there 2 y's? Yes. Okay, now you're saying, well, there's 2 y's, so what am I going to do here? Well, we need to get y out of the denominator first of all, right? So how would we get y minus 1 out of the denominator? Yep, times by y minus 1. I got to use parentheses here. Now it divides out on this side. So look what I have. X times y minus 1 equals 2y plus 3. Now we've heard this rule over and over again, so we're saying it again. If you're trying to find an inverse and there are 2 variables, 2 y's, what you're going to do is get everything with a y on one side of the equation. Get anything that doesn't have a y on the other side. Because then, if on the left side, everything has a y, can't I factor out a y, creating there only to be 1 y? Okay, so you'd say, I need to get everything with a y on one side, but we can't do that until we've distributed x in. So we have xy minus x equals 2y plus 3. Then anything with a y needs to be on the same side, and anything that doesn't have a y needs to move away to the other side. So what I'm going to do is say, I'm going to bring this 2y over near this xy. So minus 2y to both sides. Now does this x have a y? So at the same time, I'm going to add x to both sides. So now look what's on this left side. My x's are gone. I have an xy minus 2y. Then on this side, I have an x plus 3. And now what we can do is, we can say, on the left side, now I can factor out a y. And then divide by y, divide by y. So then left is x minus 2 equals x plus 3. And then look how nice, we have one last step to get y alone. Divide by x minus 2, divide by x minus 2. So my inverse, y inverse, is equal to x plus 3 over x minus 2. Okay, is the inverse a function? There's not a plus or minus, so yes, guys, that's what creates not a function, is a plus and minus. So this is a function. It has restrictions, right? But still, just because you have a restriction doesn't make it not a function. It's just it's going to jump over that point. So it is a function. The only time, guys, the only time it is not a function for our level is if you have a plus or minus. So you already know the answers to all of these. Because if it doesn't have a plus or minus, it's yes, it's a function. Therefore, the original function is 1-to-1. Ask it? The inverse is a function. So to test if the original function is 1-to-1, you have to find the inverse, and if the inverse is a function, then the original is 1-to-1. Yes. Yes. Okay, so let's do this. Here we go. All right. So, first of all, let's look at doing this one. Here we go. Okay. So what would we do? Switch x and y, wouldn't we? So x is equal to the square root of 2y minus 1. Now what? Get y alone. Square both sides. We have x squared equals 2y minus 1. Then we'll add 1. So x squared plus 1 equals 2y. Then we will divide by 2, divide by 2. So then we would have x squared plus 1 all over 2 equals y inverse. Is a quadratic a function? Yes, picture a quadratic. It is a function, right? It passes the vertical line test. Therefore, the original function is 1 to 1. Now, here's one catch, okay? Now that it's 10:50, I do think we need to talk about something. If I was to graph this, it would look like a square root graph, right? Something like that. When I graph this, it's going to be a quadratic. Isn't there too much on the inverse? There was only the top half of the square root. Does everybody see? Therefore, the inverse shouldn't have the bottom, the negative part. You guys see how we need to take off the negative part on our quadratic? Otherwise, we have too much of the inverse. So you'd say, I need to take this off, our inverse. Yeah, so we have to add in a restriction. If you start with the square root and you have an inverse, it's going to be a quadratic, but it won't be the full quadratic. So isn't it for x values greater than or equal to 0? Look at the graph here. So you take the quadratic, but only for x values greater than or equal to 0. So this has got to be your answer for your inverse. That only happens if you start with the square root. Because when you get an inverse, think about it, you'll always have a quadratic, but you won't have the full quadratic, so you got to take off the negative part. Okay. Let's do this one. Switch x and y. So x is equal to, parentheses, 2 minus y to the 4th raised to the 5th power. First step. Yep, 5th, root both sides. So now I have the 5th root of x equals, parentheses, 2 minus y to the 4th. Technically, I don't need my parentheses anymore. Okay, next step. Subtract 2. But it's not under the 5th root, so we have this. The 5th root of x minus 2 equals negative y to the 4th. Then what? We actually have to get rid of this negative first. So we have to divide both sides by negative 1. Now that means this and this have to be divided by negative 1. Does everybody see what I'm saying? So we have a negative 5th root of x, and then a negative and a negative make it a plus 2 equals positive y to the 4th. And now we're at the point where we can take the 4th root, right? We just took an even root. Just like a square root, I need a plus or minus. So my answer is plus or minus the 4th root of negative 5th roots of x plus 2 equals y inverse. Because of the plus or minus, what do we know about the inverse? It is not a function. Therefore, the original is not 1 to 1. Correct. If you start, yes. Good point. You're saying if you ever have an even exponent, when you find an inverse, it's going to be an even root with a plus or minus, so we always know it's not 1 to 1. So, let's pretend I gave you, let's pretend I didn't even ask you to find the inverse. Let's pretend I didn't say find the inverse, and I literally just said, tell me if this function's 1 to 1. Okay, so let's just test your abilities, so you don't have to do extra work on the homework. Okay. Okay, without finding the inverse, I'm asking you, is this 1 to 1? No, because when we solve, we'll have a square root with a plus and minus. True? Not 1 to 1. Is this one a 1 to 1 function? Yes, because it's a 5th root in the end, and that's fine. How about this? Yes, lines are always going to have an inverse that is a line, so it's all good. How about here? No, because of the degree 4. Because in the end, we have a 4th root eventually, at some point, with a plus or minus. So it's not 1 to 1. How about this one? Yeah, we'll have a 5th root and a cube root eventually, right? So that's fine. That is 1 to 1. And then how about this one? No, we have 4th roots, square roots, so we would have plus or minuses, so no. Okay, awesome. Okay, we're almost actually done with the lesson here. This is the last little piece here. So everybody, we learned last time how to do function composition. They're putting this into this lesson because here's a way to determine if two things are inverses of each other. We have actually already learned this in 1010, once again. This will always be true. If two functions are inverses of each other for reals, if they are really inverses of each other, then what will happen is you can take and do f of g of x. You can plug one function into the other function. And then you have to do it the other way too. Plug the other function into the other function. And if they both simplify to be x, as long as they both simplify to be x, they are considered inverse functions. So obviously there's an easier way. Remember, if I said to you, are these two inverses, couldn't you just focus on one, switch x and y, find the inverse, compare it to your answer? Yeah, so it's going to specifically say on the text, use function composition to determine if these two are inverses of each other. So you have no choice but to do it this way. You could go off to the side, couldn't you, and then do it and then know if your answer's right or wrong, you know? But you have to show it with function composition. So we need to take and do f of g of x, and it needs to simplify always to be x. And we need to do g of f of x, and it always simplifies to be x. Now if you're wondering, why does it need to simplify to be x? Well, inverses are reflection over the y equals x axis, so it needs to simplify to be x. Does that make sense? Okay, so let's do it. Let's do f of g of x. So that would be that plugged into that. So that replaces it. So we would have, instead of an x, don't I have 3x over 3? Which would simplify to be x. So we're showing our work here. So you say check, all good. Now we got to check it the other way. So now we're going to say, now we're taking this function and we're plugging it in wherever there's an x into the other function now. So replace that x with this, so that'd be 3, and instead of an x, don't I have x over 3? When multiplying fractions, don't we multiply straight across? So that would be 3x over 3, which equals x. So showing the work is getting it right. So if you happen to get it right, but your work is wrong, I have to mark it wrong on the 1050 exam. Okay, let's do another one. Are these inverses of each other shown by function composition? So let's take this, plug it in right there. So that would be, instead of 3 minus 4x, it'll be 3 minus 4. And instead of an x, I need to replace it with that. So won't that be 3 minus x divided by 4 like this? Now, this is multiplying fractions technically. So don't we have this? 3 minus 4, and then we multiply straight across. I'm going to keep it factored. So 3 minus x is on top. Do you agree? That would be on top. Then what would be on bottom? 4. What happens with my 4s? They cancel out. So now isn't my true statement 3, and then we have a minus sign, parentheses, 3 minus x. I need that parentheses, don't I? So now isn't that 3 minus 3 plus x? So I distribute my negative. So wouldn't that simplify to be x? You got to be able to do basic algebra correctly. Okay, let's test the other way now. So now we're going to take and put this one into x. So that would be 3 minus parentheses. Instead of an x, I have 3 minus 4x. And then that's all over 4. So now I would distribute my negative. So on top I would have 3 minus 3 plus 4x over 4. Isn't that 4x over 4? Which is x. So yes, they are inverses of each other. So what if one simplified to be 2x? You'd say no. If one simplified to be negative x, you'd say no, right? Okay, it's up to you guys if you need another example or if you guys feel confident. So I'll just show you this one. And we'll see what you say. Function composition, would you be able to do it? Are they inverses of each other? Yes, okay, cool. All right, what about this one? Same idea? Could you do the math? Use function composition to determine if they're inverses of each other. Awesome. Same here? Okay. All right, so I just want to make sure we know this is just putting it all together here. What do we know about inverses? First of all, to find the inverse of an xy point, you just switch x and y, right? Second of all, we know inverses are a reflection over the y equals x axis. So if I have this blue thing, an inverse, I would reflect it over y equals x would look like that. That green part would be the inverse. So if we're given an equation to find the inverse, we switch x and y, solve for y. Okay, that's the end of the lesson for today.